Hello everyone, I'm Keerti Bhave. Welcome to the session on bimetallic corrosion. Today, we'll try to understand immerse corrosion and bimetallic corrosion in particular. After going through this video, you will be able to define bimetallic corrosion, explain mechanism of galvanic cell type corrosion, and predict corrosion in combination of metals. But before we do bimetallic corrosion, I think we will revise what is corrosion and what are the types of corrosion. Corrosion is of two types depending upon the surrounding medium. When the surrounding medium is gaseous, we call it as atmospheric corrosion. And when the surrounding medium is a liquid, we call it as immerse corrosion. Remember, the word immerse corrosion is used when any liquid is involved. So, let us define immerse corrosion. What is it? It is the loss or decay or destruction of a metal when two metals are used in combination. It is called as bimetallic corrosion and it is also called as galvanic cell type corrosion. Now, before we do galvanic cell type corrosion or bimetallic corrosion, let us see what is a galvanic cell. A galvanic cell is an electrochemical device in which spontaneous oxidation and reduction reaction is used to convert chemical energy into electrical energy. It is formed when two different metals come together. Here you can see a galvanic cell where you have two electrodes, zinc electrode which is dipped in zinc sulfate solution and copper electrode which is dipped in copper sulfate solution. Externally, they are connected by an external conductor. Now, once this setup is done, there are electrochemical reactions which will happen and they happen spontaneously. You do not make them happen. So what is the mechanism of galvanic cell type corrosion? Now, electrochemical reactions which are taking place here are at the zinc electrode. The electrode material dissolves, giving you zinc ions. And at the copper electrode, the copper ions from the electrolyte accept these electrons and give you copper. Because there is oxidation reaction happening at the zinc electrode, zinc is the anode. While there is reduction reaction happening at the copper electrode, copper is the cathode. Now at this point, I want you to take a pause and think, how are these electrochemical reactions related to corrosion? Take a pencil and a paper and jot down your points. Let us again come back to the reactions which we did. At the zinc anode, zinc becomes zinc ions, that is, zinc ionizes to form zinc ions, which means zinc metal is lost or corroded. What happens at the cathode? At the copper cathode, the copper ions accept these electrons and becomes copper, which means copper is not lost or corroded. So because of the electrochemical reactions which happen spontaneously, the anodic zinc corrodes while the copper, which is the cathode, does not corrode. This kind of corrosion is called as bimetallic corrosion and happens whenever two metals come together. Now this is a reactivity series which will guide us as to which of the metals used will get corroded or not. Now whenever we have to make a choice of using metals together, as far as corrosion is concerned, we have something called as activity series. The reactivity series has many metals, or rather all the metals, put in the decreasing order of the reactivity. Here I have shown a few of them. Potassium, being one of the most reactive metal, is placed at the top, while as you go down, at the bottom you have gold, which is least reactive. Now, whenever we have to make a choice as to which of the metals will become anode and which of them will become the cathode, we refer to the reactivity series. The metal which is higher in the activity series becomes the anode and gets corroded, while the metal which is lower in the reactivity series becomes a cathode and does not corrode. So the reactivity series acts as a guide as to which of the metals will corrode or not. We take another example wherein you have a combination of aluminium and copper. Now aluminium is higher in the reactivity series and therefore aluminium becomes the anode and gets corroded, while copper is lower in the reactivity series and therefore copper becomes the cathode and does not get corroded. Now we will have a real life example. Here you have a fastener. The screws are made up of brass while the nuts are made up of steel. So it is a combination of iron and copper. Iron is higher in the activity series and therefore it becomes the anode and gets corroded, while copper, which is lower in the activity series, becomes the cathode and does not get corroded. What we find in this fastener that after some time, the mild steel nut undergoes corrosion, while the brass screws remain as such. Just let us revise what have we done today. That is, galvanic cell type corrosion is a bimetallic corrosion. Happens when two metals come together. Metal, which is higher in the activity series, becomes anode and corrodes, while the metal, which is lower in the activity series, becomes cathode and does not corrode. What we should keep in mind is that only the anodic metal corrodes. I hope you have understood it and I wish you happy learning. Thank you.